All right, thank you everyone, and welcome. It is great to have you here today. On behalf of Bravo LT, I want to welcome you to the presentation about new developments in AWS Serverless. I'm the moderator, Thomas Leinema, and in just a moment, we're going to take you all the way from an introduction to Serverless optimizations and extensions. But first, everybody's favorite part of the presentation, we're going to go over some meeting etiquette. Yeah. The presentation is split up into sections, and we want to hear from you. And in order to do so, please use the Q&A feature that Zoom has. At the end of the section, there's going to be a question mark on a slide, and I'm going to read off, and Justin will answer a couple of the questions that we have. We're going to answer as many questions as we can in the time that we have. If we don't answer your question, we're really sorry about that. There's going to be a lot of people on this presentation today, and we're going to do the best that we're able to do. If we don't get to your question, expect an email from us in the next few days that answers your question. Either way, we care, and we want to help you along in your journey as well. Please do not use the raised hand feature that Zoom has. I know you're all probably looking at it right now. We ran through a few trials of this, and the hand, for this type of presentation, it just didn't add. So please don't use it. On the chat, please only put things in the chat that would make sense to send to everyone in the presentation. So not just us giving the presentation, also the other attendees of the presentation. So be very judicious. Honestly, I couldn't think of a lot of reasons to put things in the chat. If you come up with one, just keep in mind that there's a lot of people with us today. Well, with that, let's go into the presentation. We're going to start with some introductions. And we're going to start with me. Again, Thomas Leinema. I'm a principal Java developer for Bravo LT. I'm on the leadership team there as well. And for Amway, I'm a solutions architect. So my job in a nutshell is to make things simpler, to build other people up, and to help people understand the complexities of technology and really add value to organizations. Some of the favorite things that I get to do are things like this, working with and building one of the best teams that I've ever been on at Bravo has been just an absolute joy. I have a couple of quotes there. Really like to make things simple, like to not over-engineer things, and really like to build people up. With that, I'm going to turn it over to Bill for an introduction about Bravo LT.
Thanks, Thomas. Bravo LT, I figured it would be a great time to speak very briefly about who we are, just for context for the individuals on the call that do not know. So what does Bravo LT do? We help organizations across the US find the technical talent they need to move projects forward. What that means really is that we're able to do everything from one-off staffing to dedicated Scrum teams to being able to take outsourced projects around some of the information you're going to learn today around AWS. Why do people choose Bravo? I think it's technically vetted resources by some of the individuals on the call, plus some that are able to really be able to ensure that our talented individuals are what we say they are. And then also we're able to tailor solutions, to the challenge that clients are facing. So nothing out of the box, nothing that, putting a round peg in a square hole. Really our goal is to be able to understand the challenge and deliver upon it. So how to engage? My email address is right there, bill.osborne@bravololt.com. More than happy to answer any questions you might have. Maybe a great option to use the chat here would be to reach out to me that way as well. But Justin, over to you.
Okay, thanks a lot, Bill. So some of you may know me or some of you may not, but I've been working in the IT industry for about 60 years, and I've been working with AWS almost that entire time. I've always been fascinated with cloud computing from the start. I've managed to pick up 12 AWS certifications, and I've even explored multi-cloud picking up a couple certifications in Azure and GCP as well. I was recently joined to the AWS Community Builder program in October last year. And I'm also an ACloud Guru Insider. I'm working currently as a senior software developer at Bravo with Gordon Food Services. And I was working previously as a cloud architect at Verizon. So now I'm going to move on to the presentation, and I'm going to start with a couple introduction definitions. That way we're all on the same level. From the poll results, it looked like not everyone is familiar with AWS, so I want to set that stage. Okay, so moving on to some introductions. First one is what is AWS? It's Amazon Web Services. It's a cloud provider. It's been the leader in cloud providers for over 15 years now, and they have the most services. They release at the fastest pace, and they're a really great option if you're looking at getting started with cloud. And they have millions of customers all over the world, and they can really help you out in multiple ways. Okay. What is serverless? Serverless is a way to build applications without having to worry about the underlying infrastructure. So you can just worry about your code, and it helps you move faster and provide some automatic benefits. We'll talk about the benefits actually on the next slide. But you just set up some event triggers, and then the cloud provider worries about giving you the infrastructure when you need it and taking away when they don't. And that way you're only paying for the infrastructure as you're using it and not when you're not using it. Okay, so here are some of the benefits that I mentioned. So you get automatic scaling. So if your configured event happens multiple times, then you'll just get multiple invocations in parallel. You have high availability and fault tolerance through the cloud provider can provision your code to run on any of the servers that they have available. So if some of their servers or data centers are having issues, then they'll just provision your code to run on a different server that doesn't have those issues. So you can avoid issues like that. You have reduced operational overhead because you don't have to worry about patching the underlying servers or maintaining them. And you can get to market faster by spending more time on your applications and less time worried about those other things that I just mentioned. You're not paying for idle time. So if you don't have any events firing or you don't have those triggers, then you're not paying for that, which is really nice if you're working on a proof of concept or an application with a variable workload. Okay, so here's that question mark Thomas mentioned. When you see this on the slide somewhere, then we'll be taking a short number of questions in that section.
All right, Justin, we got a question for you. Now, there's a lot of benefits on this slide. And I know with the clients that we've worked with at Bravo, which one of those benefits are they most looking forward to?
I think for a lot of businesses that are currently operating but not operating in the cloud, could see benefits in the agility. So with the traditional architecture, like you might have mentioned a little bit before the call started, we have to the procurement process takes a long time for servers, and you have to make sure you get the estimations right. So you have to benchmark your application. You have to know how much CPU you need, how much memory you need. Whereas with serverless, you can kind of just deploy it blindly, and it'll automatically scale to meet your needs. So, and then you can scale it deploy whenever you need, and you have multiple avenues of doing that through the console, CLI, SDK. You can do it programmatically as well. So skipping the procurement and switching to an operational expense model as opposed to a capital expense model can be very beneficial to some businesses.
Yeah, thank you. Yeah, I know I shared some stories before the presentation began, but I remember lugging 30-pound or so, Dell pizza boxes, we called them, and then, climbing upstairs in order to install them in a rack. That's not a very agile exercise. It's exercise, but I wouldn't consider it agile.
Right.
Now, one more question on this part for this section. to the people on here who are kind of old school like me, I started in IT 20 years ago, before this existed. Some people are on here like thinking, is serverless going to affect my job? How is it going to impact my job? Do you have some thoughts on that?
So I've heard this concern as well, that some of these services could replace some people's jobs, but I don't think of it that way. I think of the people that would spend time patching servers, well, now they have time to spend monitoring serverless applications or doing something similar, but not exactly the same. So as long as they get the training they need to understand the services that they're going to be working with, I don't think job security is really a concern here.
Cool. I'd say that too. I think, you know, at Bravo, when we do tech interviews, we're looking for a few things. And the ability to understand and to solve technical problems goes such a long way. And it applies to whichever environment that you're working in, whether it be cloud or, you know, just anywhere that that needs those specific skills.
Right.
Cool. With that, we're going to move into our next section, which is serverless services. So we know a little bit about serverless. We talked about it on in this portion. And now it's, well, what can we do with serverless? You know, we talk about some of the benefits of it, but can we actually take advantage of those benefits? So for this section, be ready, because we're going to go through a lot of servers, or a lot of services. So you may want to take notes of it, and please feel free to send us a question too if you want us to dive more into any of those services. Let's go.
All right, very nice. Okay, so here's some serverless services on the slide. A lot of people hear AWS Serverless that they think immediately Lambda, right? But AWS Serverless and AWS Lambda are not the same thing. AWS has several serverless services, some of which are just mentioned here. And I'm going to go through different categories. And I just kind of like handpick my favorite services for each category to discuss them briefly, so you can get an idea. But there are a lot of serverless services, and AWS is releasing at a very rapid rate. There's no possible way I could talk about all of them, even if I really wanted to. But a lot of these services are purpose-built services that AWS had seen a trend of common use cases amongst their millions of customers, and decided to build a service that was optimized to fit the needs of that solution. So if you have that use case, a lot of times it can be beneficial to use these purpose-built services as opposed to trying to roll your own solution with something like Lambda, which could be done, but might not be as efficient or as cost effective. So we'll talk about some of those. And I wanted to give special attention to these bottom four services: EMR, Kinesis, MSK, and Redshift. These had historically been on-demand services where you had to pre-configure like the EC2 instance that would be used or the throughput that was required for these services. But at reInvent last year, they announced that there are now serverless offerings of these services as well. So you can do Redshift for data analytics without having to pre-configure your nodes, which is incredibly powerful. All right, so now dive into the different categories. First, we have analytics, and the first service there is Athena, which is a query service that lets you query data stored in S3 using SQL. So if you want to upload like JSON or CSV files, you can query that data using SQL. And it's serverless, so you only pay for the data that's scanned. And I've even used this service to build like a database type thing for low cost, low traffic serverless applications. Next one up is Glue. This is a data integration and preparation service. It's used a lot for preparing and analyzing data for machine learning and analytic pipelines. Okay, next one is Kinesis. This is a streaming service that's used to process and analyze data in real time. So if you need to do something like fraud detection, or if you need event-driven architecture that need to respond to events rapidly, then this would be a service that you would probably use. Moving on to the compute category. First, we have Fargate. This is this lets you run containers with the help of Elastic Container Service or Elastic Kubernetes Service if you're using Kubernetes, and who's not these days. without having to worry about the underlying servers. Okay, next we have Lambda. This is probably the most popular AWS compute service. It's lets you run code without provisioning or managing the servers behind them. And we'll have more slides on Lambda later because it's such a crucial part of the AWS serverless architectures. So I'll come back to that. Then we have App Runner. This makes it easy for you to deploy containerized web app and APIs without having to worry about scaling and without having to worry about the infrastructure underneath it. All right, now I'm going to talk about serverless databases. First one is Aurora, and Aurora has a on-demand offering as well, where you use where you pick like the server type, but it also has a serverless offering. And this is a MySQL and Postgres compatible relational database with a lot of nifty features like backtrack. If you need to rewind your database a couple days in the future because someone messed up or dropped a table they weren't supposed to drop. There's Dynamo Database, which is the most popular AWS serverless database right now. It's a AWS proprietary NoSQL database that performs at incredibly high performance. It's a key value store. All right, then we have TimeStream. This is a time series optimized database. So it's similar to a relational database, but optimized for performance and cost when specifically storing and sorting by time. So if you're capturing multiple events, then you want to look at TimeStream. It's also I think it's the newest AWS database, which is pretty cool. All right, some integration services. We have SNS, or Simple Notification Service. This is a messaging service that enables app-to-app and app-to-person communication. You can use it to send push notifications. You can use it to send emails or even trigger off a workflow or a pipeline. SQS, Simple Queue Service, is a queuing service that lets you decouple and build distributed applications. It's used heavily in microservice architectures, whereas if you have multiple microservices that need to communicate with one another, you can decouple them by having them communicate to the queue instead, and then your applications only need to worry about the queue. They don't need to know about one another. All right, and then last one for this section, we have step functions. This is a workflow service that's used for orchestration, and it's used to build distributed applications that can tie AWS and third-party APIs and services together. And you can do some advanced features here, like parallelism for executing tasks in parallel. You can do branching logic if you need to do like if-then conditions based on the result that you got from a previous step. You can do retries here, and there's like a dead letter queue and some configuration options. It also has a visual and a programmatic interface. So if you're a visual user, if you don't have a lot of coding experience, you can use a drag and drop interface to interact and build your pipelines. If you're more of a programmer, you can use a JSON-like language called states language to build out this state machine definition. And you can use the CLI or SDK or a tool like CloudFormation or Terraform to deploy it. All right, and then the last category we have is storage, and I was only able to find 2 serverless storage services, which is pretty surprising given the number of services that AWS has. But the first one is EFS, or Elastic File System. It lets you have like an NFS type file system where you just write your files to the file system and you can read them from multiple locations. It can connect to EC2 instances, it can connect to on-premise servers, it can connect to Lambda functions. And you don't need to provision how much storage you need. You just write files there and it'll grow. And also there's some advanced controls there as well. Okay, then the last one is S3. It's probably one of the most popular AWS services of all time. It's one of the oldest services of all time. It's an object storage service that lets you upload files. You can upload files as large as 5 terabytes, and it grows infinitely. And you have built-in encryption and versioning and monitoring and a lot of fancy controls. You can do static website hosting on this if you want to run a simple like Angular website without having to worry about the servers underlying. You can do that. Okay. And Neva can take some more questions.
Cool. All right. Yeah, it's a lot of info in this section. It really is. especially if the services are new to people. And we had a couple of questions on this one, and there's one that I had too, because I'm used to setting up our own services. I think we do it with EC2, and when I see servers and Lambda and all of that, and we go along the progression of virtualization and making things really, really small to the point where they're serverless, there's a couple of computes, things that we talked about in the compute section. And we have a question on that, and that is, what are the reasons for using Fargate versus Lambda?
Okay. So it kind of depends on what you're trying to achieve. If you wanted to leverage Kubernetes for your architecture, then you would want to use Elastic Kubernetes Service, and Fargate would probably be the easiest serverless offering for that. Lambda has some limitations, has 15-minute execution max, so you can't really exceed that. If you're using Fargate, you could probably go past the 15-minute execution time if you needed to. And if you wanted to leverage some of the other benefits along with Kubernetes or containers like a Docker file, then you could do that with Fargate, and you can't necessarily do that as easily with Lambda.
Is Lambda more on the event-driven side of the house then?
Yeah, for sure. With a Lambda function needs an event to fire it, and you can configure the event to be like an HTTP trigger if you want to get an HTTP endpoint and call it that way if you're building APIs. But maybe App Runner might be better for that. It just depends on what you're trying to build.
Cool. Thank you. We have one more on, and I think we're going to get into this more, but I want to address it as well. We mentioned both step functions and Lambda, and as a developer, I'm thinking, I see step functions. I can just code that, right? I can code these step functions. I don't even need them. When would you do that? When would you use step functions over coding something in a Lambda? What is the difference there?
I think if your process is really complex, and if you want to get that oversight, so like yes, you can just chain a bunch of AWS services together within code if you want your Lambda function to write to a Dynamo database table and then to send an email through SMS. Then yeah, you can do that if you want. But you could also use step functions to write that record to the Dynamo database table, and you can use it to send the notification for you. And I think you get better visibility if you do it through the workflow, and you get those fancy features out of the box without having to custom develop them, like retry. So what happens if the email doesn't send? Okay, step functions can retry that step. Oh, what happens if that part fails? You can write code in Lambda to catch that exception, but step functions can do something else. So it's just trade-offs you have to make.
Cool. It reminds me of it's pretty big in microservices, the concept of sagas, and having step functions like a graphical saga that you can have all of the processing and roll back and the different types. Is it a repeatable operation? Is it something that we can only do once? Orchestration sagas. Yeah, Ryan's on the right page there. I know we have a couple of questions that I know some of these are going to be in another section. So the one about SNS and testing, we'll get to that. All right. Well, let's hop into our next section. We gave you some services and maybe some ways to kind of connect them together. We kind of teased that with these step functions. Justin, can you put a nice bow on this? Can you talk about serverless architecture?
Sure thing. All right, so here's the next section. First, I'm going to talk all about Lambda because it is important to know. So like I said, it's an event-driven compute service. You upload your code and you can run it when those events happen. The cloud provider will provision the servers for you on the fly. And it usually happens pretty fast, less than a second in most cases. There is an issue of like cold starts, but that typically only happens if you're using like a compiled language like Java, or if your application needs to do something really intensive on boot. All right, so it exposes the memory configuration for controlling the power optimized or allocated to your function. So as you allocate more memory, then your function becomes more powerful, and you can get more CPU and more network bandwidth. And we'll cover that a little bit more, how that works later. It easily integrates with other services. Like I said, if you want to write a file to S3 and have that trigger a Lambda function, it's very easy to set up, and it's a very common use case. If you want your Lambda function to write to a NFS file system, then you can easily connect to EFS to do that. So the AWS integrations are there. All right, it's built per request in 1 millisecond increments. So if your code only runs for 100 milliseconds, then that's all you're going to be built for, which is really nice. You don't have to pay too much if your code is executing very quickly. It lets you optimize down past even below a second. Okay, it automatically writes logs and metrics to CloudWatch, so you can use the native programming language tools like system.out and console.log, and those logs will flow into CloudWatch. You can do more from there, like ship them to Splunk if you need to. You can also analyze them within CloudWatch itself. There's some built-in features like CloudWatch logs metric filters that you can use. It supports a lot of popular programming languages out of the box, like Java, Golang, C#, and Python. But it also recently supports container images. So if your popular programming language isn't supported yet, or if you're using a version that isn't officially supported, you can build it as a Docker container and then deploy it as a Lambda function. Okay, a newer feature about Lambda, which was actually just released last week, is called function URLs. So this assigns an HTTPS endpoint to your Lambda function. That way you can simply call it without having to integrate API gateway, which was what we had to do before this feature. And API gateway is really great. It's still going to be used in a lot of production architectures because it has an advanced feature set. But if you don't need those features, then you can use the built-in function URL to improve agility and to get to market faster. So this announcement aligns more to the serverless benefits that I talked about before. All right, now using the best service for the job. Like I mentioned when we first got to the AWS Services section, you can do almost anything in code, and that gives Lambda a lot of power. But like Matt Coulter said at the reInvent conference, code is a liability, not an asset. The less we can code, the better, because our custom code will probably break. And using the purpose-built services that I talked about before, or other ones that you find, can provide a lot of value. So they provide a lot of functionality that would be hard to replicate, and using them instead of building out the same functionality in Lambda will probably be cheaper, and they may even be cheaper to just use the services as opposed to like the Lambda requests. I'll read this quote that I like: complexity is liability, ensure the cost is worth the benefits, by Thomas. Yes. I'm trying not to reinvent the wheel when you're going through this. If you need to use Lambda for like business logic, then that's great, but make sure that there's not an alternative that you can leverage before. Okay, now I want to talk about this announcement. September 21, Step Functions announced or added the ability to integrate with AWS SDK. So before that there was only a handful of integrations that existed. So there was 17 API services or AWS services you could use, 46 API actions you could use. Now with the SDK integration, you can use over 200 AWS services and over 9,000 API actions. So before, if you wanted to use an AWS service that wasn't officially supported, like let's say you wanted to write a record to the time stream database, then you would have to write a Lambda function that did that by interacting with time stream, and then you'd have to use the invoke Lambda integration to call the Lambda function to then write to time stream. Now you can just write to time stream directly using the SDK, and you don't need to worry about that. You also get the visibility from the step functions perspective, and you get the step function perks as well, like the automatic retry that I mentioned earlier, and some other stuff as well, like monitoring, logging. I think we're ready for questions here.
Yeah, we had a question in the last section that I think is perfect for this. And it coincides with my thoughts on that everything needs to be tested as a developer, and that, you know, the more complexity, the more moving parts that we have, the more difficult things are to test. So when we have a complex structure like this, where we're using an event-based, we're using SQS, SNS, Lambda all together, are we able to test and debug that locally?
So I'm not going to say you can't, because, you know, anything's possible, but I definitely wouldn't recommend it. And it's true that monoliths might be easier to debug because you can trace them, trace the request from start to finish without jumping around. But AWS provides some tools that you can use to help debugging serverless applications. One of them is called X-Ray. So this will trace your applications and build a service map of what's happening without having to, without negatively impacting performance by taking a small sample set of your requests. There are other things you can do. I know in the past people have tried to like mock the AWS services or try to emulate them. But I haven't seen a lot of success in those areas, probably because AWS is releasing at such a rapid rate that the latest feature sets, the latest functionality won't be available in those emulated versions. So what I would typically recommend people do is they set up a dev or dev test in AWS account and test these things live. So if your application reads from an SQS queue and then sends a notification through SNS, then build those services out and test them live in that dev AWS account. There's tools like CloudFormation and the SAM Accelerate. SAM is serverless application model from AWS, and these tools can help you deploy your infrastructure changes rapidly into the AWS dev environment. That way you can test. And SAM Accelerate tool will even stream the logs from CloudWatch to your local machine. That way you don't have to switch screens back and forth to try and see what's going on there. I hope that helps.
Cool. It helps. And I think this talks to the testing pyramid, right? Where at the bottom we have our unit tests. And if we're just unit testing, we can use fakes, for example, as opposed to testing the real thing. Once we get up to the high level where we're running integration tests, those tend to be brittle even in monolithic architectures. And they're just more frequent here. It's one of the difficulties with serverless is that the testing is going to be more moving parts. I would recommend looking at things like infrastructure as code to try to build up some assurance that the infrastructure is out there. And there's some also some monitoring that can go along with those to ensure that that infrastructure is up and running. And that should build some assurance that it's at least running. But after that, it's almost always an integration test, and yeah, by nature those are inherently brittle.
And
all right, we have one more question, but we'll get to that one at the end. We need to hop into our next section, and then I'll catch the question in chat at the end.
Okay.
Because,
so now,
yeah. Oh, I had an intro for this one, man. No, that's all good.
oh, I'm sorry. Next we have we're going to talk about pricing, because serverless pricing can be kind of complex. It's definitely a lot more difficult than buying a server and paying for that server 24/7, right? So I'll try to demystify some of the confusion around that, and then we'll talk about Lambda optimization next. All right, so here let's look at a couple different Lambda pricing scenarios. So Lambda bills for the duration per request. So, and then also based on the memory that you configure and the architecture used for that function. So if your function runs for 3 seconds and you configure half a gigabyte of memory and you get 500,000 requests a month, then these are what the prices will look like for the different architectures that you have. $12.60 a month for an 86 architecture, or $10.10 a month for an ARM architecture. Now the ARM processors are known as Graviton 2 processors. These are AWS built, and I'm thinking that's why they can offer them cheaper than the 86 chips or the 86 processors. But you have to see what works best for you. And I'll talk more about Graviton processors in the optimization section of this. But just note that they're always going to be a little bit cheaper than the other ones. Okay, so the second scenario is almost identical to the first one, except for the requests are 4 times as much. And as you would expect, the price is 4 times as much. So there's nothing there. It's just, all right. Then on the third scenario, I want to highlight that the memory is twice as much. So now we have a gigabyte of memory, but the function executes in 1/3 of the time before. And you actually cost savings. So it's more, the charge is higher for each millisecond because the memory is higher, but it's running for 1/3 of the time. So overall it's less. And that's some of the importance of making sure your memory optimization is correct, because you could be overpaying if you have the wrong memory configuration. So in a lot of cases, maybe you could raise the memory and get better performance at a cheaper cost. Okay, so that's Lambda. I'm going to talk about some of the pricing for some of the services that have both a serverless and non-serverless offerings, because it can be complicated. So I'm talking about the EMR service right now, or Elastic MapReduce. It's an analytics service that is used for big data analytics in the cloud. So using technologies like Hadoop and Apache Spark in like a clustered environment. So this is, imagine we have M5 extra large, which has a preset number of CPU and memory, 4 virtual CPUs and 16 gigabytes of memory. And then those are the prices for that. So $192 an hour for that server, and then 0.48 cents for using the EMR service as a premium on top of it. Okay, and then if you look at the serverless price for the same amount of CPU and the same gigabytes of memory, it's actually 26% more. And this might be surprising to some people, but it's like a convenience feature. So they're going to charge you more for serverless because it's convenience. And it might make sense to use on-demand offering if you're fully utilizing the resources that you're paying for. I say that because maybe your application needs six virtual CPUs instead of 4. So you have to scale up to 8 because there's only pre-built server offerings. You can't scale one independent of the other. And paying for 8 CPU instead of 6 is going to be more expensive. So in that case, serverless wins. And with over 400 EC2 instance types, can be daunting, and you're almost guaranteed to not be using the right one for your workload. So, and maybe you don't know your workload. Maybe you're releasing a new application with an unpredictable workload. It would be frustrating to deploy one configuration and then have to stop it and redeploy a different kind because you didn't have enough memory, or you didn't have enough CPU. With serverless workloads, you can scale your memory and CPU independently. So if you have a very memory intensive application that doesn't need a lot of CPU, then use a bunch of memory and not a lot of CPU, and then you're only paying for what you're actually using and not what you need there. Okay. So moving on to how you can tune some of these things. The first tuning control you have for Lambda is that memory configuration I said. And a lot of people might not know this, but you can allocate multiple cores to Lambda by providing more memory. So Lambda functions can actually benefit from multi-threading if you allocate enough memory to that function so it can get those cores. But you'll have to experiment to see if that's actually saving you any money, or if that's better for your use case, implementing multi-threading and raising that. If you look at this example I took from the AWS documentation, they show a 10 times memory configuration makes the function 10 times faster, and it is only 1/100th of a cent more expensive than the 120 gigabytes or 128 megabytes. So don't always assume that less memory is going to be cheaper. If your function runs longer, then it'll probably be more expensive. Okay. Next, I'm going to talk about these Graviton 2 processors that use the ARM64 architecture. If you're using an interpreted language like Python or JavaScript, then you can just switch the architecture in a Lambda function and you don't have to recompile your code. You don't have to change your code at all. So if you're using those languages, it's really easy to experiment to see if you get better performance, if you get those cost savings out of the box, then maybe you should do that. If you're using a compiled language like Java or C#, it's a little bit harder because you have to recompile your code to be suitable for those processors. And if you're using containers, what some people don't know is that you can build your container in a way that satisfies both architectures. So there are container images like Nginx that have support for both architectures. In those cases, you don't need to rebuild the container image. You can just deploy the same onto both. Some of the claims of the Graviton processor from AWS that it gives you the highest performance when compared to 86, 20% lower cost for the same function, and up to 34% better price performance for total cost of ownership. But I don't think that this is a blanket for everything. I think you have to test both architectures with your code and your application and see if it's worth the switch for you. And I wanted one more note on this slide. Graviton 3 processors were announced at reInvent, but currently they're only available for EC2 instances and very select few. They're not available for Lambda functions yet. Hopefully that changes soon. And we'll see an increase in these numbers here. Okay, the last tip we have for tuning Lambda functions is this project on GitHub called Power Tuning. It's a state machine powered project that uses step functions under the hood to run your Lambda function multiple times with different configuration options. And then it plots it so you can see a graph and make a data-driven decision on which memory configuration works best for your function. So here's that graph blown up. You can see in this example here, 1536 memory is the best performance and the best cost. And just blindly increasing your memory will have some plateau effect. So like doubling that to 3 gigabytes does not provide any faster execution, but it does increase the cost. Okay, so we can take questions for this section.
All right, this is an important section, and it's a lot of detail, and it almost feels like we have to walk through one of these in order to understand it better. But if we don't have that, if we don't have serverless already, and we're just moving from our existing architecture, are there ways where we can estimate what the costs will be before we get there so that we know it's going to be a valuable move for an organization?
Yeah, there are there are tools that are out there. I found some websites that try to allocate your AWS bill. If you switch to Lambda, you tell them how much cores you're using, how much memory you're using, stuff like that. There's also the AWS Pricing Calculator, which can calculate your Lambda bill before you build Lambda out, which is helpful for forecasting. But if you also look at your application and there's some cases where you just know it's going to be cheaper. So like if you're doing your application isn't running 24/7, maybe it's only running some days out of the week, or you have a lot of downtime, you have a lot of idle time, serverless will probably almost always be cheaper in those cases than running on demand all the time. Or if you're building out like a proof of concept, those two. Sorry.
Cool. All good. I think it harps on event-driven architecture again, because being event-driven versus being, having like an open socket and accepting something, it's a very different world. And when things are event-driven, if you have hours of gaps in between events, or if it's infrequent, it sounds like it's almost guaranteed that this is going to be a less expensive option.
Yeah, exactly. Or if you have those maintenance processes that only need to run once a week, once a month, move those to Lambda, because you don't want to pay for those to just sit idle most of the day.
Yeah, good point. All right, we have one section left, everybody. In this one, yeah, we made it, man. This has been fun. Thanks for hanging out with us this afternoon.
Okay.
Our next section is on extending Lambda. Now, a lot of companies will have third-party relationships. I'm over at Amway right now, and I know, we use Dynatrace for observability. We all use Splunk for logging. We use various third parties. And one of the inhibitions of moving to the cloud, maybe that we have to learn all new ways of doing things, and we have to give up the existing ways. With serverless and AWS, that's not the case. Justin, can you let us know how it works?
Yeah, exactly. So like Thomas mentioned, there's a lot of popular third parties out there like Dynatrace and Splunk, and these companies saw the trend in serverless, and they created ways of providing their product in serverless architectures as well as in server-based architectures. So, and one of the ways they do this is through Lambda extensions. So extensions are a way where you can write a piece of code and then share that code among multiple Lambda functions. So you can plug this into your Lambda functions and reuse it. So if you want to add some instrumenting or some diagnostic information, you can plug that in. So this would be like Dynatrace monitoring. And then if you need to fetch some configuration data or read some secrets from like HashiCorp Vault or AWS Secrets Manager or System Parameter Store, then you can do that in like a setup extension and then plug that into your function. You don't need to rewrite that code over and over again. If you're familiar with the developer principle, do not repeat yourself, then you can use that here. Moving on, a little bit more about extensions. Here are some of those providers that have pre-built offerings that you can just plug in today and start using them. You can also write your own extensions if you're so inclined to do so. And here's some important things to know about them. So the extensions will be initialized before your function code runs, which is really important if you're doing like monitoring before your function runs. You want your monitoring agent to be listening, right? So that's important. Performance. The extension will share your Lambda's resources. So the memory allocated, the CPU allocated to your function will be shared by the extension. So if you're allocating a gigabyte of memory, then that gigabyte of memory is shared for both. So if your extension is doing something intensive, then you need to make sure your function has allocations to support that. Which leads me to pricing. There's no additional charge for using Lambda extensions, but if you have to scale your function to support them, or if your function will run longer, either because of the startup or the cleanup that the extension is doing, then your Lambda pricing could go up to allocate for those. And then for security, your extensions will share whatever Lambda IAM permissions are granted. So if your Lambda function has access to DynamoDB database, then so does your extension. And if your extension needs access to SNS, then you need to grant that to your Lambda function as well. Yeah, I hope that's clear. And that's all the content we have. So now we can take all the questions we didn't cover yet, other questions, and then questions not related to presentation directly.
All right, well, people type those up. I have two of them that people have asked during it, and one, a nice one that I like about when we run these extensions. When we have to pay for their cost, does it run on every invocation of the Lambda, or is there a context that it runs in where it does not have to initialize every time?
That's a good question. So if you're familiar with the Lambda execution lifecycle, and I wish I had a graph to show or a diagram to show you, when the Lambda container is initialized on the AWS hardware, it will run the extension at that time, and then it'll reuse that container for multiple invocations within a short period of time before that container dies. So your extension will run only after the cold start. Like during the cold start phase where everything's being set up, it'll run then, and then it'll be shared across all invocations after that.
Got it, thank you. And we have a question on testing that I saw and I didn't know if we could answer it or not, because I think we touched on it a little bit, but probably not to the extent of that's being asked here. If we have a bigger project, how do we test that in Lambda? And I'm going to preempt this with Lambda isn't really intended for big projects. So if we're thinking something that's like a 2 million line code monolith, it's not the right use for a Lambda. So when we say bigger, it's going to be relatively bigger.
Yeah, nicely said. some people build out Lambda lifts, like they're referred to, and that's actually an anti-pattern. You want your Lambda functions to be small, to do one thing and to do that one thing very well. So if you have a lot of code there, you could try to analyze it through CloudWatch logs and use that tool I mentioned earlier, AWS X-Ray, to try and give you some more insights there. You could even ship your CloudWatch logs into a different provider like Splunk if you're not getting the analysis that you really need to, or move the logs into something like Elasticsearch and use Kibana if you want to dive deep into that.
Cool. All right, we have another question that came up on Q&A, and it's about the extensions. And I know extensions is a new feature. I don't know how many of you've used, Justin. So it's going to be it's a tough question.
Okay.
So have you, in your experience, have you identified some of the lower impact extensions that provide monitoring functionality?
So because well, what I was saying earlier, where the extensions only run during the cold start part of your function, if you're receiving a lot of requests, you typically won't see a lot of cold starts. You only your containers will be reused a lot of times. So the impact of plugging in one of these extensions to do monitoring with like Dynatrace, I imagine to be relatively small. But I haven't personally done any benchmarking or experiments with that.
So cost-wise, should we be concerned if we're adding an extension? Like if we have a contract with Dynatrace and we put it into our Lambda and wrap it in there, are we going to see like another $10,000 on our bill, or another $10 on the bill?
I would definitely think not. I think any extension costs will be probably negligible. And when you plug in your extensions, I wouldn't say don't add an extension and then jump into the configuration options. Add the extension and then keep your function as is, and do some monitoring on that. Maybe the extension causes your function to time out a little bit more often than you would like. Okay, then you take that information that you have and then raise the memory slightly, or raise the timeout slightly, but don't change anything too much, and then the pricing won't change at all, right? Because your function configuration for the timeout and the configuration will be the same. So
yeah, makes sense. So that's all the questions we had. So I have one for Justin, because a lot of people ask him this on social media. It's rare to find someone who has all of the AWS certs. Like, I don't know how many have that. It's a bit of a unicorn that people get that many certs. Do you have any recommendations for people who are, oh, and we have another question. So you have about 2 minutes.
Okay.
Do you have any recommendations for those looking for a similar career path who want to get certified in AWS?
Yeah, so yeah, it's pretty unique to have all of the AWS certifications. I did that mainly as a personal goal, but at some point it definitely plateaus and you won't see any career benefit from that. The AWS certifications are built to be role specific. So there's like a machine learning specific certification if you want to be in the machine learning space, solutions architect, developer, etc. So really, it's best for people to target which role they want to be in, and then only achieve the certifications that lead up to that role. When I started learning at AWS, I just wanted to keep learning more and more. And one easy way I found to do that was to go for certifications, because they challenged me to look at other aspects of the AWS cloud that I haven't looked at yet, and to actually familiarize myself with those two standards that AWS will also recognize.
Cool.
Okay.
Thank you.
That helps.
All right. One more question, and then we're going to wrap it up. It's about extensions. Are they versioned? So can they automatically be patched by the vendor, or choose a specific version if there's a bad release? So can we roll it back? And this makes me think about dependencies in Java, where I live a lot of the time.
Interesting. Honestly, off the top of my head, I don't remember if they are or are not. I would think that they are versioned, just for that fact that we don't want them to release something new and break it. But I'll have to look it up after this call, honestly.
That one, we'll send you an email on that one and follow up and get you a complete answer on that one. All right, with that, it's only 3 minutes till we got to get back to work. So I want to thank you all again for joining us. It was, well, and thank Justin especially for all the practice and all the time that it takes to write the presentation like this, and Bravo LT as well for putting this on and enabling us, you know, as workers of Bravo to put this on. Like I said, I very much enjoy the community aspect of it, and yeah, thank you. There is a short survey. It was when you exit the meeting, you'll be presented with a short survey. Please give us some feedback, even if you can just type some things. We'd love to hear from you. Like I said, it's been a long time. Like, you know, we're working from home now. It's great to get feedback and to hang out with people. So very much appreciate you spending time with us today.
Yeah, nicely said. Thank you, everyone that had joined. I hope you learned something new. I hope you were interested and entertained. Yeah, I look forward to seeing your comments and on the survey.